Okay, 8th graders, today we're talking about discrete and continuous domains. And our essential question for today is, can you decide whether the domain of a function is discrete or continuous? So we need to first define what a discrete domain is. And a discrete domain is a set of input values that consists of only certain numbers So a discrete domain is only certain numbers. A continuous domain is a set of input values that consists of all numbers. A set of input values that consists of all numbers. We'll add in an interval. So I'll give you an example. A discrete domain would be, if we looked at it on a number line, it would maybe look like just the whole numbers, 1, 2, and 3. A continuous domain, if we looked at it on a number line, would be everything. So 1.1, 1.01, 1.02, 1.2, everything in here would be a continuous domain, and only the numbers 1, 2, and 3 would be a discrete domain. So until this point, we've only talked about discrete domains. We've been able to say it's just these x values, and it would just be a few of them. So let's look at our first example. The function y equals 15.95x represents the cost in dollars of x tickets for a museum. Graph the function using a domain of 0, 1, 2, 3, 4. So we filled all those into our table already. Is the domain of the graph discrete or continuous? So if I do 15.95x, so that would be times 0, my output would be 0. And my ordered pair then is 0, 0. If I buy only one ticket to the museum, it's $15.95 times 1, which would be $15.95. And my ordered pair then is 1, $15.95. If I buy 2 tickets to the museum, I would do $15.95 times 2, which I'm going to use my calculator for. And I get $31.90. So my ordered pair is 2, $31.90. If I buy 3 tickets to the museum, I would do $15.95 times 3. And I get $47.85. So my ordered pair is 3, $47.85. And if I buy 4 tickets to the museum, I would do $15.95 times 4, which is $63.80. So my ordered pair would be 4, $63.80. Okay, so I filled in the rest of my table, and if I look at this data, and I think about what I'm actually using here, I'm talking about the number of tickets, right? Could I buy half of a ticket or a fourth of a ticket? Is my price ever going to be anything other than what's already here? Of course not. So I can buy 0 tickets, I could buy 1 ticket, I could buy, 10 or 100 or 500 tickets, but I'm never going to have anything other than what you see here. So this is going to be a discrete domain because it can only be these numbers. We can't have 1.1 tickets or 1.5 tickets or 4.5 tickets. We can only have 1 or 2 or 3 or 4 tickets. So this is a discrete domain because you cannot buy part of a ticket. Let's take a look at the next example. The function m equals 50 minus 9d represents the amount of money m in dollars you have after buying d DVDs. We're going to graph the function and tell is the domain discrete or continuous. So, if I have $50 and every DVD I buy takes away $9, then my graph, I'm going to count it by fives, 10, 15, 20, 25, 30, 35, 40, 45, 50. 1, 2, 3, 4, 5, 6, 7 DVDs maybe. Okay, so if I buy no DVDs, I would have $50. If I buy 1 DVD, 50 minus 9 would be 41. If I buy 2 DVDs, 50 minus 18 would give us 32. So if I buy 2 DVDs, I would have $32 left. 5, 10, 15, 20, 25, 30. If I buy 3 DVDs, 50 minus 27 would be $23. If I buy 4 DVDs, 50 minus $36 would be $14 left over. If I buy 5 DVDs, 9 times 5 is $45, I would have $5 left over. So I can buy at most 5 DVDs with $5 left over. Is this domain going to be discrete or continuous is the question that we need to answer. Well, can I buy part of a DVD? Savion, what'd you think?
Discrete.
Yeah, it's discrete because I can't buy more. I can't buy half of a DVD, right? It wouldn't do us any good, would it? You're famous now, Savion. So it's discrete domain because I can't buy just part of a DVD. Okay? Turn your paper over. Our next example says a cereal bar contains 130 calories. The number of calories consumed is a function of the number B of bars eaten. Graph the function. Is the domain of the graph discrete or continuous? So if my cereal bar contains 130 calories and the calories consumed is a function of the bars eaten, I would have an equation that says, okay, if I eat 0 bars, how many calories would I eat? 0. So my ordered pair is 0, 0. But if I eat 1 bar, each bar contains 130 calories, so I would have eaten 130 calories here. So my ordered pair is going to be 1, 130. If I eat 2 bars, I would consume 260 calories for an ordered pair of 2, 260. If I eat 3 bars, I would consume 390 calories for an ordered pair of 3, 390. And if I eat 4 bars, I would consume 520 calories for an ordered pair of 4, 520. So on this one, you can eat part of a cereal bar, right? I could eat 1.5 cereal bars. In the middle of 1 and 2, it would be somewhere around 200 calories. So this one would be continuous. Because I could eat even 1/10 of a cereal bar. So this one has to be continuous because we can eat part of a cereal bar. On the next example, a 20-gallon bathtub is draining at a rate of 2.5 gallons per minute. The number g of gallons remaining is a function of the number m minutes. Graph the function. Is the domain discrete or continuous? So we start here with a 20-gallon bathtub that's full. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So here are my gallons. And here are my minutes. And my bathtub is draining at a rate of 2.5 gallons per minute. And could I drain the bathtub for part of a minute? Sure. So I could, even go all the way down to seconds or half of a second. So since that's the case, this is going to be a continuous domain because I can drain the bathtub for part of a minute. I don't have to do 1 minute at a time. Okay, are the data shown in the table discrete or continuous for the number of stories of this building? Well, let's look. The number of stories, so the first story makes the building 12 feet high, the second story makes the building 24 feet high, the third story makes the building 36 feet high, and so on. Could I have a 2.5 story building?
No.
No?
Yes.
Okay, we have a disagreement. I would say most of the time we don't have like a half-story building. There's the rare occasion like,
If you have a rooftop garden, you would have half of that being garden, half of it being
house. Okay. So, I would say but the normal thing would be to have only full stories. Like if you're at a hotel or a house or a building, it's going to have a certain number of stories and not have like a 1/10 of a story or 1/100th of a story of a building. So is this then going to be discrete or continuous? Discrete. Because we can't have part of a story of a building when we're talking about most buildings. So it has to be discrete because we can't have part of a building. Alright, on the last page you have some problems to try. So I've provided you with graphs. There's only 3 problems. You need to graph the function and tell is it discrete or continuous. And then the word problem, you also need to tell if it is it discrete or continuous. Everybody say hi to your classmates.
Hi. This was brought to you by Jamal Linger.
I'm on YouTube.
Okay, have a good night.